will have a similar. Okay. All right. Thank you. Is it good? All right. Oh, so this demo application, you see, well, I think you guys are familiar with this user interface. We have a menu bar, title toolbar, right? Status bar there. And status bar, you can also include a progress bar. So when the training started, you will see the track bar keep tracking the progress of your training somehow, right? And this user interface is for user to specify the layer, number of hidden layer. So initially it's one, hidden layer is one. And probably user like to have deep learning neural network somehow. Well, so he can keep adding a layer to this solver. But normally, it's because the data set we are dealing with is a small data set, so normally, you probably just need one layer will be totally enough. But probably you will wonder why. And why currently we are talking about deep learning neural network? Well, because you are going to deal with large size data set, especially when the input neurons, if the number of input neurons larger than 100, definitely usually use multi-layer precision, more than one hidden layer. But usually for small data set, usually you just need one layer. You can try it. It does not guarantee. That means if you add more layer, it does not guarantee the training result is better than the single layer. Just try to think of that. You try to somehow find a knowledge. The knowledge is actually a function, complex function, right? In terms of the output should be in terms of your input, right? So if the knowledge is so complicated, definitely we need more parameters. Well, in neural network, the parameter is just the weight, right? If you add a link connected two neurons together, definitely you will add one weight. That is a parameter to your equation. So think about this equation. If you think the knowledge is complicated because it involves a large dimensional input and also very complicated knowledge, then you definitely need to add a lot of layer, add a lot of inner neuron between the input and output layer. But if your data set is small, you don't need to bother any so-called deep learning neural network at all. So don't be frightened by those studies where some studies just doesn't make any sense at all because they claim they needed to use deep learning neural network, but the data set is so small. If the dimension is probably under 100, definitely you don't need to use DNN to solve your problem. Our multi-layer precision can solve the problem nicely. Okay, so but anyway, your application, since we are dealing multi-layer, right? Multi-layer precision. So usually let the user this kind of freedom. If a user like to add as many as a layer, hidden layer, well, it's okay. Your system still can deal with that. And then for each hidden layer, user can specify. You see, user can specify the number of neurons within this layer. So user can can increase the number of neurons there, right? So that is the main user interface. So in this case, it's well, to some extent, it's a deep neural network somehow, right? And right now we kind of use so-called backpropagation, right? Backpropagation method is generalized data rule. So the learning rule is all the same for. So nowadays DNN or CNN they are using the same automation techniques. That's the generalized data rule. So basically we need the information about the gradient, right? Gradients on each layer, and then propagate back to the front layer, and then so we find the delta weight, and update our weight. So you will see the error will keep reducing somehow. But remember that since the general data rule is a hard computing automation techniques, your training might stack up on some local minima, so you are not going to get further improvement at all. That is the fate. Of hard computing anyway. So for the learning on neural network, you can choose different kind of automation techniques. For example, our GA can do that. Our PSO can do that. Do what? Do training, right? So basically, for GA and PSO, from the viewpoint of GA and PSO, since they are meta-heuristic algorithm, actually they are dealing with an automation problem. What is the target? The target is the weight. The weight on the connection link between neurons, right? The whole problem actually is a big function f, y's internal x. We try to model this function as a multi-layer perceptron. The variable just that weight. The variable should be weight. And how about what is the optimization goal? Optimization goal is that for all the training instances, when they are performing forward computing to the end, we try to minimize the error to the global minimize. That should be 0. If all training instances, once you get a solution or the weight, make all the training instances forward compute and the error compared with their target value is 0, then you get the global optimum, right? So in addition to the backpropagation, so-called generalized data rule, you can use all kind of optimization meta-heuristic algorithm to train your neural network. So since right now you have your GA library, right? But GA library, you need to add another encoding scheme. That should be a real number encoding scheme. So once you compare that modular, you can add your GA to here to train the neural network. But definitely you have PSO, right? If your PSO is correct, you can use the PSO to train your neural network to see what is the efficiency, what is the effectiveness of the PSO in training the neural network. All right. Okay, so before we start, we need to open a data set. So data set have input dimension and output dimension, right? So the input layer and the output layer is not specified by the user. So user does not have any freedom to modify that, because that depends on the training set. So right now we have read in breast cancer Wisconsin machine learning database. So right now, well, let me show you if I kind of reduce the number of layers into just one layer, and what I might need probably just 4 neurons. So it's very simple. So you can calculate how many weight or appears for this model. We just have one hidden layer, and the hidden layer just have 4 neurons. So input neuron will be 9, right? Because so you have better. If you like to make your application much more friendly, you should provide some user interface to display the content more or less. For this data set. So user might know that, oh, okay, this data set has input dimension 9, output dimension 2, because the class just 2. Either way is a cancer patient or a health person, like that. So that is your responsibility. To add more user interface to let the user understand what kind of problem he has read in. Okay. All right. So what kind of parameter we can set for backpropagation multi-layer perceptron? We have epoch limit, right? Epoch limit. It's quite similar to what? To our iteration, right? In meta-heuristic algorithm, we cannot evolve our best solution iteration by iteration, right? It's similar. Well, so epoch limit is that once you feed in all the data set, all the data instance once, then you compute one epoch. So usually the stopping condition should be epoch limit. Initial eta, right? Initial eta, so that should be eta is sub-0, right? Eta should be given special by the user. And know that if you have trouble in training the neural network, you need to think about changing the initial value. So once we complete an epoch training, we kind of reduce the learning rate, right? So the simplest way is that we just multiplied the current learning rate with a constant factor. So the naming wise is sometimes confusing, because in neural network we call eta learning rate, Well, that's respect to the gradients concept, so it's kind of rate, right? I understand. But we still need another factor, try to reduce the amount, try to reduce the amount of this learning rate, epoch by epoch. So we have learning rate. Well, so this is learning rate, what I mean. Learning factor reducing rate. So you had better add a description, I mean, on your property in order to not get your user confused. Initial eta, initial learning factor, suggest the value, right? 0.1 value. Learning rate. So in here, in my opinion, my learning rate is actually not reducing factor. So it should be always larger than probably 0.9. Otherwise, your learning rate will gradually, will be largely reduced. It's not good at all. We just like to keep the learning rate. Well, actually, it's kind of step size idea anyway. Keep it reducing a little bit, I mean, for each for epoch by epoch somehow. But you are not going to let it drop quickly. So these tools are probably the most important factor. I mean, the user can specify when the user training the neural network. And if you look into the slide, I may talk about some ideas to improve the learning to improve the learning efficiencies. We call momentum. If a user turn on the momentum, then this momentum factor will be in effect. So if a user choose true, then this factor will play a role in updating the weight. Okay, so check in, just look into the slide if you like to implement that to make a comparison without momentum means techniques. What is your learning effect anyway? That will help you understand the training of the neural network a little bit. Training ratio is because we are using KDEP file. KDEP file does not separate the testing and the training data, so user need to specify ratio. Usually, probably two-thirds of the data will be used for training and 1/3 for testing. But that can be specified by the user anyway. So we let the user specify this factor. So basically, what you need to do is that once you read the data, you need to do the linear mapping, and then try to use a random number, draw these portions of data for testing. Okay, so these are the default value, right? 500 and initial data probably that should be 0.7. So we can start training, reset everything, because user might try different kind of parameters, right? And then do the training. So we have a reset button there, which is also similar to the meta-heuristic algorithm, right? All right, so user can train the multi-layer precision epoch by epoch. So train an epoch. So once we have finished an epoch training, we have well, in deep learning we call it lost, and in our multi-layer precision we compute the root mean square error, right? Because the root mean square error has an absolute value. Each neuron, the neuron, each value should be start from 0 up to 1, right? So this error, root mean square error, can let us know. I mean, once we read the value, we will know whether this training good or not. If the value, if the value, root mean square error, smaller than 0.1, that means 1/10 of the value range, then your training probably might have a good result. But if your root mean square keep it floating around probably 0.3, it's not good at all. So once you test the data, then you will get low accuracy. Okay, so user can train epoch by epoch. So as you can see right now, root mean square has dropped to 0.15. Train epoch, train epoch, train epoch, train epoch. All right, but remember that our error, our root mean square error, which is not similar to meta-heuristic algorithm. Meta-heuristic algorithm we keep a best solution, right? But in here we simply report the room square error or each epoch. So probably the initial training will be keep reducing, but finally it raise up, which means you have overtrained your neural networks somehow. So you need to monitor the progress of the room square error during the training. All right. So user might want to train to the end. I mean, train the neural net until it reach the ending stopping condition. So user click this button, train to end. All right. So as you can see, the error, the room square error dropped to 0.1. So probably we can get great result. And right now in this demo application, I kind of let it automatically test it. So the testing result has been generated. So if you like to execute it once again, all right, you skip this, click on this button, the result should be the same. So what I'm saying is that training to the end, the button has taken care about this button click. So once you hit this button, reset this button, at the end of the training, it also carry out the testing. So right now the accuracies of this training result, the accuracy up to the 97%. I think it's acceptable anyway, to some extent. So this is what I'm saying is a confusing matrix, confusing table. So the diagonals is because class 0 has been class 2 group 0, so they are correct. Class 1, 90 instances belong to class 1 has been grouped into group 1. So these are the correct testing. But again, there are 6 incidents has been wrongly grouped into 2 wrong groups, right? So the accuracy is now 97%. So once you finish your implemented a multi-layer, you should try that. Try to specify different kind of parameter to see what is the training result. For example, if I reset the initial value probably into 5, which is very large, right? 5.0. Then you start everything, right? Then the training start all over again to see whether the training result is okay or not. As you can see, the room square is higher than 0.1, right? So it does not guarantee that once you change something, the result is better than before. Okay. So how about testing result? Well, again, it's 0.97, so still is okay, right? Well, but the room square error is not good at all. So somehow you need to find it out. And probably I can also change it into 0.1. Small, keep this better. Keep what? Keep your weight difference calculation small, right? If you put a small value there, then the weight update is always with a small amount, trying to end. Again, the room square does not less than the 0.1, but the classification accuracy is still acceptable somehow. So, and how about this learning rate? Learning rate keep reducing. If I drop it somehow, let the amount of learning rate drop quickly. So I probably times 0.6. So each time the learning rate times 0.6, probably 4/10 value has been reduced somehow. So the modification of the weather keep reducing quite quickly. So in that case, let us see what will happen. You see, the room square does not drop at all because the modification amount just a little bit. So that will make your training inefficient, right? But again, you cannot. So probably I make initial values very large, and also that the amount quickly drop. So you see, this kind of parameter setting, there is only certain rule can guarantee which one will be better. But usually you should once you are dealing with the data set, you should try it by yourself. Okay, run to end. You see, in this case, the error message, the room square, there is no any change at all. On the contrary, the training accuracy and the testing accuracy is poor, right? Don't mention that 0.62 is good, it's over 0.5. No, because all the second set has been wrongly classified, right? 90 has been put in here. This 90 should be in another way. All right, so parameter make difference. So during the neural network usage, you need to try the parameter, but not just so let us change it back probably to 1, and then learning rate reducing, not just reduce so quick. 95, 96, all right. Trying to end. It's not good at all, right? So 0.99, you set trying to end. Probably 0.7, you set trying to end. All right, somehow like that. All right. Okay, is there any question? And also another parameter is what? Parameter is the hidden layer number, right? Neural number. So if I increase a little bit about the number of hidden neuron, right? Probably make it maybe change it to 10. Reset to see if the training is improved. Again, the final room square is still larger than 0.1, so it's not guaranteed. It's not guaranteed, right? So there is no any guarantee that more neural network, more parameters, more weight will generate better accuracy at all. No, there's not any guarantee. Okay. So you need to try on this parameter changing. If you really like to learn machine learning somehow, especially using neural network, for example, some of you guys, your research group might work on deep learning neural network. So you need to get some experience on the data training, more or less, right? But again, if I have 10, right? I have 10 neurons specialized on this configuration. The generalized data rule does not give us a good result, even though the accuracy is 0.96, right? We can ask GA try training this model for us. So right now, what GA is dealing with is that you have a neural network with one hidden layer 10, so a bunch of variables. Well, the variable should be in real number encoded, right? So I can generate GA solver. You see, this is the GA parameter setting, right? Crossover rate, iteration limit, mutation rate, population size, deterministic selection, and the selection option is that what kind of crossover calculation you were using. We have a convex, we have a affine. You can check the slide. I have mentioned the formulations of this crossover there. So if you like to implement your own GA solver in real number encoding, you can follow the slide. All right, so user can obviously choose the one. So reset it. So right now I use GA try to train this neural network. So I can run to end. The accuracy is right here. So this is the power of GA, right? So we are dealing with the same goal, right? Try to reduce the room square error. So that is the achievement of GA. So basically, users can also change the parameters. So if I change it back to 4 neuron again, let us train. Let us use the backpropagation. Well, this time it's not good. Initial data is still too large, right? 0.7. So we try to get a result from the backpropagation. Again, it's a little bit higher than 0.1, right? So with the same structure, let me use GA, try to solve it. And I did not change it. Probably I should use another one, a fine crossover, run to end. So the result is almost the same, right? But I can keep increasing the iteration count and properties mutation increasing a little bit, and population I might employ 50 close amongst them. Reset, run to end. Well, there's a tendency that I can keep reducing, right? So let me set iteration into 1000, reset, run to end. So you will see the user interface does not update. I mean, in real time, right? That is because the computation keep it doing the evolution. It does not have enough time to update the user interface, so it's kind of late right there. And today, if I have time, I will show you how to do that. I mean, how to do a so-called multi-thread programming to avoid this kind of latency. Okay, so you see, we can get a better result than the generalized data rule. How about PSO? Remember that if you use meta-heuristic algorithm to train a neural network, what you are dealing with is a bunch of variables. The number of real number is not just two-dimensional at all. No, definitely no. The dimension is probably 100, 200. So your automation problem, the number of real number probably might be higher than the 100. So in that case, PSO is very poor. Let us see what happened. I mean, in PSO dealing with the same structure. We just have 4 interneuron, right? Reset, run to end. Probably I should set, is equal. So again, 1000 iteration, right? And since you have 50 chromosomes, so I have 50 particles. How about the configuration? How about this factor? Cognition factor, social factor, maybe a little bit more higher. So we have a versatile solution. Somehow reset, run to end. So this time we use PSO to train our neural network. As you can see, it's poor, right? It's very poor. The mean square never drop. So don't appreciate PSO at all, even though it's much easier to implement. For higher dimension, PSO is a garbage. Sometimes if you have a grading method, you can get a solution better than PSO. Well, we can expect that because number of parameters, defined in the PSO is just 2, right? So if the model is too simple, definitely it cannot solve complicated problem. So you can make this kind of comparison. So I like to you guys what I'm emphasize is that you do the program all by yourself, so you know what kind of meta-heuristic is better for what kind of problem. So later on, once you get a literature using the meta-heuristic to solve the problem, you might have a proper critique on the result. You might wonder, wow, how come if you are using GA solve a permutation problem, how come you can get it so get a solution so beautiful? Then probably something wrong there. You can critique that. Okay, so PSO is not good at all. GA, the operation of GA is still some kind. Sometimes is still activate somehow. It's in general better than the generalized data rule. So remember that GA is so computing wide, right? So from an automation viewpoint, we don't need to use any gradient information. But gradient generalized data rule, neural network itself is a so computing techniques, right? But the learning has been using the hard computing way, generalized data rule. So we need to know the gradient in order to evolve the sets of weight, right? Okay, so pretty much that works your interface. But today's, well, if you take a look at the complete demo application, as shown in the slide in the videos. In that case, we have graphics draw, right? Showing up properties in your application. So today I'd like to show you, I'd like to let you learn a little bit more about the graphics. So remember that in TSP problem, I prepared that graphics capability in my library. You don't need to bother about drawing, right? Draw the route somehow. In that case. But this time you can try use some space. On your application, try to show the structure, at least the structure, right? So let the user know what kind of neural network structure he's dealing with, right? It's much more better for the user. Otherwise, the user know nothing about where is your neural network really constructed? It's very ambiguous. So we like to let user. In this case, we like to show up somehow. Okay, so we like to let the user. In this case, okay, right now we have. We have nine input neuron. We have 2 output neuron. We have just 1 layer with 4 neural number, and then there is a connector link together. And then, if you like, you can show a weight, current weight right there somehow. All right. So we like to have a graphics display for our neural network model. Why? People might appreciate what you have done, right? So you can see how much complicated your structure is. So later on, like this one. All right. So there's a connect. So in this case, it's much simple, right? Because we just 4x2. Oops. There. So we have to show up this kind of graphics on the panel, right? It's a panel. So okay, so far is there any question about this final projects? Okay, so if you know, I would like to introduce you graphics on C# programming language. So let me prepare the solution first. Okay, so if you like, you can follow. I'm not going to lay out all the user interface for you, but for some structure I still need it because, for example, the multi-layer persuasion class. So, all right, so I have project. Make sure it is on the desktop, and the name wise should be research, right? R07 assignment 12, right? Okay. Win application, win for application. So roughly, we will have probably we don't need to have any menu bar, but we will have a toolbar, right? So we have tool strip, status strip, and then between them we usually shall have a split container. And within a panel or a split container, we might add another split container. And split container contains 2 panels that can be oriented vertically. or horizontally. All right, so suppose right now, like the linear work drawing on the panel 2 or the second split container, right? So rename split container 2 SPC second. So right now we know the target is panel 2 split container SPC second panel 2, right? So before learning the graphics, let us try something. Let me just draw something. So I might add a button here. Maybe I just undock the split container 1 to let you see what happened. Feel, right? So I remove it. Okay, so now we have these panels, and I have better use some big color to let you see the area, the range of each panel. Big color, big color. Okay, so there's the differences. All right, so remember that in drawing we need to have a certain kind of coordinate system, right? And coordinate system or uniform application, for each panel, this is the panel, right? So the top left corner is the original or the coordinate system. This is screen coordinate system. So this is local coordinate system for this panel 1. How about this panel 1 or the second split container? The coordinate origin is in the top left corner. So every control is the location of the control is specified with respect to the coordinate system or its parent. So as you can see, the bottom one right here, where is its position? Location, excuse me. Location is right here, 48, 30, 34. You mean what? Left, start from, I mean, this is a coordinate in terms of this coordinate system. So 48 pixel, 34 pixel. So the positive direction of the y-axis is downward. Remember that? Origin is right here. Y-axis is downward, so it's kind of left-hand coordinate system. If I move it, as you can see, right now, the location of this button, you see, the top right now is 3 pixel, 62 pixel. So remember this kind of scheme. So each panel has its own, because it's the container, it has its own local coordinate system, especially it's on the top left corner in pixels. Okay. So if I subscribe button one's event, try to do something, try to draw something on somewhere. So basically, the graphics can be drawn either on this toolbar, on phone, on panel 1, on button 2, or it is on the status tree too. Never mind. But if you want to draw something, you need to get an object called the type is graphics. Get a graphics drawing graphics from that component, from that panel first. Okay, so suppose I like to draw something on the phone. So I mean this right? This is the phone. This dot create graphics. Create graphics is a function or any container type control. So what you get is a graphics object, graphics graphics object. So once we call it, we get its graphics also. We need to store that graphics. I might call it G. So right now, what I get is the graphics tool. It's a graphics object. Actually, you can think of that as a device, a graphics display device. Sometimes that might be a printer. So once you draw something to printer, then you print something out. All right, so it's an abstract concept. It's an abstract device anyway. So right now G is actually the screen, right? So the screen is in pixels coordinate system, right? So we got a G. Then you can use G to draw a lot of things. But usually for drawing, we usually deal with a range on the screen or on the printer, right? So there is a struct called ICT rectangle. So I might have a rectangle area. And this rectangle is later on will be in terms of coordinate system or the form ICT, and then we initialize. This is not essentially we initialize it with some kind of value. For example, XY, right? So there are three ways XY. That means the left coordinate, top left coordinate, and the width and height. So if I have specified that as X maybe just 5, Y maybe I need 25. How about width? Width my special 50. About height 100. Okay, so I have rectangle specified. The rectangle do have a coordinate system associated with that, right? So basically we will have left 5 pixel, top 25 pixel, width is 50, height is 100. Then we can draw it. So G dot draw. You see, a bunch of drawing function is provided in this graphics class. We can draw arc, we can draw Bezier curve. Bezier curve is cubic curve. It's cubic curve. Ellipse. Even draw an image icon. Draw image. Draw line. Draw path. Draw pi. So I mean, for our neural network, we might need to draw ellipse. So if you specify the rectangular width and height the same, then definitely you get a circle. You will draw a circle. So, and also we might draw some numerical value, right? So you can draw string. You can draw string, draw rectangle, draw polygon. All right, so we draw it. No, not draw polygon. Draw rectangle. If you want to draw something, you need to specify the color and the width of the boundary. So we need to have a pen. Well, since I don't have any pen, so I may use a pen stock pen. Stock pen has been specified within this class. Pens. It's a default pen. You can regard it as a pen bank or pen, or a library of pen. Anyway, it's prepared. Dot, special color. So suppose I like to use the red color. So I specify the first parameter. The first parameter asking me to provide a pen. Then how about the next parameter? Well, just the rectangle, right? Oh, I can put a rectangle there. I see. That's it. So I kind of get the graphics from the form, all right? And then I specify a rectangle, so you will draw a rectangle there. So let's see what will happen once this button is clicked. So as you can see, it means the 5 pixel, right? This is 5 pixel. How about 25 pixel? The origin is in this top left corner, not the current area. Okay, remember that the origin is right here. Origin is here. So it's 25 pixel. Width is 50 pixel, and height is 100 pixel. So I draw this guy here, right? So similarly, I might try this. Let me modify a little bit. Okay, so I get a G, and then, well, maybe we just make these lines grouped into another function. So we might have VOID, draw, and take a parameter graphics G there. So we like to move this line into a function, then we try to call it. It will be much it will be much easier for us to make a multiple core for that. So since we have G ready, right, so we don't need this one, and then we move it here. Okay, so if you give me a G, then I draw a rectangle there. So this time I get a G from the graphics, right? So I can call this function and put G there, right? So it's the same. The functionality is totally the same, right? So you can try it. Draw a rectangle there. All right, fine. So what is the point? The point is that, okay, I draw the same thing, right? I can draw again, but this time I ask what? Button one, create graphics. This time, draw. Split container 1, species second, fine. Panel 1, get graphics, create graphics, excuse me. Create graphics. Draw. SPC, split SPLI, split container 1, panel 1, create graphics. See the point? This function just draw. Well, if you give me a graphics device, it's an object. I draw there a rectangle. All right. So once I click on it, see everything has been there. Right. So we have all these rectangle drawn on different side. But pay attention to what happens. See, when I move cursor out of this button, it's gone. Why? Because once you move your mouse off the button, it generates an event. Do you remember what kind of event? The mouse left event happened, and when this event happened, Windows operating system took over the job. Windows operating system try to withdraw this button, this control for you, but Windows does not recognize you have drawn something there, so it's gone. All right. So if I try it again, see when I reduce this window size, see what happened. Okay. So right now the split container 2, panel 1 has been cut out, clipped, right? When I enlarge it, see part of them disappear. But again, once the panel has been clipped, it will generate an event. Once it is extended, then the Windows operator try to redraw the panel. But there's nothing special in the redraw function, so nothing will be drawn again. So again, similar things. So if I move everything down, it's gone. It's gone. It's gone, right? So this is not the way we like to have. So if you really want something appears from the beginning up to the end, stay there, you are not going to draw it dynamically. You need to special a draw it function on their pen event. All right, so let me show you how this is done. So right now, I subscribe panel 2, the pen event of panel 2. So I click on this panel 2, right? There's a Thunderbolt there. Probably I should subscribe panel 1. No, panel 2. Okay, it's panel 2. So there is a pen event. So this time I subscribe it, double click it. So each time, if panel 2 has been tear up or have been reduced or resized, Windows operating system will automatically call this function. Not for you. It's just the duty of the Windows operating system. Once the Windows has been destroyed or need to repent, the Windows operating system will generate a pen event, and then since you have subscribed a pen event, the Windows operating system will call your function anyway. So in that case, we should put the drawing function here. All right. So how can we do that? Well, again, I should still ask a draw function. But should I prepare a graphics G equal split container to split interesting. I should have SPC second, right? It's SPC second. Panel 2. Create graphics. Yeah, you can do that, but it's not necessary because this pen event is always generated by SPC second panel 2. So since it is generated, this event is generated, by the panel 2. So all the detail has been stored in this argument, in this parameter E. So actually, you don't need to specify your own graph G. Actually, you can directly specify from the E dot graphics. So then, this event handler function can be specified by the rest of the panel, right? Because each panel will have their own graphics specified within these parameters. So we simply draw it. So as you can see, from the very beginning, this rectangle has been drawn there. Even though the window has, well, let me show you again. So I draw everything again right here, right? Once I move it, it disappears. So when the Windows is closed, reopen, Windows operating system call your pen function, handling function. So in that case, you can have your graphics, appears on your panel 2. So that is the whole idea. So once I destroy the form again, your rectangle still exists there. Okay, that's the way we like to have. So that is why, if you remember in the TSP projects, I provide a function there, specialize that for you. So you need to subscribe that draw event in your pen event handling function there. Okay, I think it's about the time we take a short break, then we will continue with this topic. So before we break, is there any question about what we have done here? All right, so we take a break. Okay, let us continue. So what kind of stuff we can draw anyway? Besides the draw rectangle, so we might have draw a circle, right? So we can try something here. So with the same rectangle, okay? So I can not just draw. Draw is actually just draw the boundary, right? So we can fill in an area. So if you type fill, F-I-L-L, you can see you still can fill a lot of stuff. So let us fill an ellipse. So if you are using fill, then you need to have a brush, because you need to paint this area. So you need to have brush. If you don't have your own brush, so actually, see, if you are looking into this function call, you might prepare a gradient brush. So that will make your figure have a gradient effect anyway. So they don't let you try that. But if I do not have a special brush, I might use default brush. BRUSHES. This is a class. This class prepare a bunch of stocked brushes. So simply use this class as its property with color gold. For example, GOLD, fine, gold color. So in order to fill an areas, you need to prepare a brush first, and then the areas, the bounding areas. So right now we try to fill an ellipse, right? So using this rectangle as a bound, I see there. Okay, let us see what happens. All right, so you see, this is the fill ellipse. So right now we have gold card special there. If I draw everything, you see a bunch of ellipse has been drawn there. How about line? Okay. Similarly, we can have another draw function. G draw line. Line needed again similar. It need a pen, right? And also 2 point 1 and point 1, point 2. So when I prepare local variable point p1 equal new, actually it's not an object. Okay, it's a struct. So I specify coordinate xy. Maybe it's times 5, 25. The corner, upper lip, top lip corner of this rectangle. And how about the other point? P2 equal new point. So, well, REC dot left plus REC dot width is x coordinate. REC dot top plus REC dot height. Probably you know what I'm doing, right? REC top plus REC dot height. Actually, I draw a diagonal of this rectangle. So this time I use different kind of color, pens, black, or maybe dark blue, or dark red, dark cyan. Okay, dark cyan. P1, P2, right? P1, P2. So again, run it. Take a look at what will happen. All right, dark cyan color corner, right? So every draw content have diagonal draw it. So it's draw line. How about text? Draw text. Okay, G dot draw text. You see, we still can draw image. String, excuse me, draw string, not draw text. So the first argument should be the string you like to draw. NTU, IIE, try it. And then, since it's a string, right? So you need to specify font. If you do not have your own font, you can use the font associated with this form, right? Remember that form 1 has a font specified there. You see, form 1 we already have a font property there. See, font, and this one is not good because it's Chinese letters. It's so thin. So I like to have change it. So right now my default font is Microsoft Gen Hey. This kind of font, I prefer that. Okay, so go back to the code. The second argument is that, well, just this meaning the form, the object form, font. Also, I need a brush. Fine, I use the stock brushes, BRUSHES. That, and this time I might use dark blue, DARK, dark blue. And then you need to specify the point. The point is the string, the top left corner of your string, where should that should be serve as the starting point. So you need to specify a point. And this point, if at this point I just specify P2, the last P2, right? All right. So I will print this NTUIE from P2. So let's see what kind of result came out. See, NTUIE start from this point. This point is P2. So that is the way you print the string. But sometimes I like to make the my string appear. For example, right in the center of this rectangle. So I can use a rectangle to frame my string. So I can align this string properties in the top, in the middle, in the row, in the bottom, with respect to this rectangle. So in this case, you need to have another object help you to do that, to do the formatting. Okay, so this guy, we will call it string format. I think it's string format, right? Let me try it. String format. String format. That's F. You need to instantiate an object for this string format. New, new format. And also we need to specialize some characteristics about this string format. Okay, so in this case, right here, I use this SF dot align. There are three kind of options. It's the so-called string alignment. It's the vertical alignment. It's an enumeration, all right? So select one, string alignment dot center. Let me try this first, center. Another alignment is a line, vertical alignment, SF dot line alignment. We need to specify the property. Similarly, is a string alignment, center. Alright, so I have a string format specified. Then I can draw another string, string. This time I might call it, I use Chinese letter. Font, same. I think somebody put a font there. Brush. Purple. So this time I'm not going to specify the point. So I'm not going to invoke this function invocation at all. So rectangle, no, not this one. This one. I invoke the fifth function called string, font, brushes. Oh, okay, I need to special brushes. Yeah, brushes has been done. And then special rectangle. Initially, it accepts the flow. If you have a fixing letter F, meaning that is the data type is a flow. But right now, my rectangle is an integer. Is okay. It can be converged. REC right there. String formatter. So that means this string will be print with respect to this rectangle. Okay, so let's see what will happen. See, 台大公公 right here, right in the middle center, because we specify center, right? Okay, maybe I just delete these two lines. Did you see the relative position? So center. Okay. If I like to specify in the top, dark in the top layer, right? So the vertical, so line, the line alignment. The option is called near. It's very strange. It's not top left down, and it's near. See, this is the near, just in the top. Far, as you can see, it should be the bottom. If I specify far. Okay, it's the bottom. So you can arbitrarily, specify the position of your string with respect to a rectangle, and dark either way. It's in centers or left and right up there. All right, so probably that's it. But if sometimes we like to use up all the spaces, right? For example, this panel 2. Suppose I like to draw an ellipse just cover all the spaces of this panel. How can I do that? Definitely, I need to know the width and height of this panel, right? But how about this one? How about the other one? How about the bottom? The sides are different, right? So I cannot just simply draw everything. You see, if I like to have an ellipse, for example, cover up all this area, cover up this area, cover up all the area. So how can we do that? So you need to have another information about the range, right? About the range of this graphics device. So in that case, I might ask the user, I might rewrite a little bit about this function. I'm not going to just, you are not going to just give me the G. You need to give me another rectangle. I call it bound, B-O-U-N-D-S, bounds. So once I get the bounds, then I can draw, for example, I can G dot draw ellipse PNS pens. Well, this time probably I will show you how can you create a pen with different kind of feature, right? So suppose when I prepare a pen, I call it my pen. You need to new it, instantiate it. So what kind of constructor we can have? Color, right? Color, brush, width. Well, probably this one is what I want. Brush and width. Okay, so suppose I have a B-R-U-S-H-E-S, brushes, Oliver. Width. This time I try 5 to see what happened. So I prepare a customer pen, then I use this pen, my pen, to draw this ellipse, my pen. How about rectangle? Oh, okay, I just draw an interior ellipse for this graphics device bounds. Okay, so I got this one, right? What I have done, draw. So since I have changed a little bit about this rectangle, right? So in this case, I need to add everything. So right now, G, this is with the form itself, right? We have bounds. See, we have bounds. And then bottom one, side should bottom one, bounds. 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 Oh no, I made a mistake. Actually, I'm not using this one. It's okay, bounds, because that is forms bounds. Bottom one, this one is wrong. Actually, use SPC second dot panel one dot bounds. And this one should be the speed container one, speed container one, panel one dot bounds. And how about our subscribe pen function? Because the graphics has been stored within this E, right? How about the bounds? You see, the beauty is right here. We have special E dot quick rectangle. Quick rectangle. It's not in terms of bound property at all. Because it's a parameter passed in by the graphics device. So and they just define the rectangle, the bound as the name quick rectangle. So that's it. All right, so that is what happens. See, the very beginning has been drawn, and since the width is 5, so you see maybe just 2.5 points. I mean, it has been cut out somehow because the width is 5. So, and you see when I drag this. Oh, okay, it's nothing happened, right? Nothing happened. Let me later on. Let me show you how to do that. Okay, so how about the bottom one draw? Check it. Well, I made a mistake, right? Bottom one bound. Bottom one bound. Panel is okay. Panel is okay. Panel is okay. The form itself is not alright, right? Form is not alright. So I want to call it this bound. Should we call client rectangle? Client rectangle. Bottom one bounds. Panel one bound. Panel one bound. Let me check the drawing first. So I draw it. Yeah, this time is okay. See, button has been erased because oh, okay. Try it again. Well, buttons does not right. Buttons left corner. Button one. Button does not look up here. See, this is correct rectangle, so everything is there. Fine. Bottom one bound. Do I have any view? It should be the bottom. I don't know why. Interesting. It's a little bit weird anyway. All right, so that is the whole idea. So right now, graphics has a bound, right, specified by the user. So it's almost ready. So right now, what can we apply this kind of drawing to our project? So suppose right now your project right now you have we have a class, right? So we add a class. It's a class. And then we call it MLP, multi-layer perceptron, right? I'm not cover everything. So initially, what I need probably just the 90 array, and we call it the N. And suppose that right now we have 9 input, 4 hidden neural network, 2 upper neuron, somehow like that. So in MLP, we will prepare the draw function in MLP. Why? Because all the data has been kept in MLP, right? So how many layers and how many neuron has been specified within the MLP. So drawing function definitely should be provided by MLP, not by the form. All right. So we have a function public void draw neural network, and then this function similarly will ask graphics, but it is not recognized, right? Because when you add a class, the namespace is using just the general one. So this guy has been special in where graphics has been special within the system drawing. So let the wizards help you add this line using system.drawing for you. Graphics called G, rectangle, REC, we call it bounds. So prepare this function. So right now you need to print a layout somehow. Print a layout. For example, what you have is a bound, right? So what is the size of your neuron? So probably we'll have a neuron int radius radius. So what is the value? Because the bound has been changed, right? Dynamically changed. So you need to figure it out, or your radius somehow. And also prepare, this arrangement. So probably is what I what I have in my mind is that int width, wi might be bounds width divided by number of n dot length plus 1. If we have three layer, then we divide it to the width with 4 parts. 4. Okay, so I have width. Alright, so and neuron. So radius I might decided. So neuron is related to what? Usually related to the height, right? So I might have radius equal bounds height divided by the largest number, right? The largest number of n. So I need to go through int arge equal n 0 for int I equal 1 I small n dot length I plus plus if n I large and large equal n. Somehow I just get the largest one. Some of you might prefer using max, right? Some of you guys keep using max, mean, average. It's not good. It's not good. Especially for meta user algorithm, it's not good because when you invoke this function, behind this function, the CPU loops through all the elements once. So usually you can use one pass, calculate the average, calculate the maxima, calculate. But right now, if you keep using the maxima index, each time the CPU will look through your array from the beginning to the end. It's quite costly. So don't, as possible as you can, don't use this max average, the aggregation function. It's provided by the extended function or C# programming language. You should check the largest value by yourself. So then divide it by largest plus 1. So I get a radius. Well, actually it's not radius, right? I might change it diameter anyway. I might call it neuron width. Okay. Alright, so I have W radius. I have neuron width radius. So I can start for int, that should be column, int c equals 0, c smaller than n length, c plus plus. And then I need to prepare a rectangle, right? So actually I do not have need a special neuron width anyway. So I can have RECT rectangle, REC equal new, initially 0, size 0, will be okay. And then neuron width, I don't need to have it. Simply say REC dot width equal REC height equal bound divided by larger than 0. So I keep everything in RECT width. Okay. So right now I have width and height. And probably now is not good at all because I need to have some space, right? If space take 1/2 of them, I might have 1.5. 1.5 meaning what? 1.5, 3.3, sorry, 3 times 2 width height is a little bit different. Well, anyway, you can figure it out by yourself anyway. All right, so and then I have how many? I mean, int h equal what? Equal height, bounds height divided by n call it C plus 1. So write in H. And then int y offset equal bounds height minus h time IC height. No, offset no. We have h. No, h time n sub c and minus IC width divided by 2. This is y offset. Okay, so H high, right? It's okay. So RECT dot REC left, no, X equal C time W minus REC width. I try to REC width divided by 2. So I will look through all the neuron INC rho equals 0, rho less than n dot c plus plus. So I have specified the y coordinate with y offset plus rho times h. So I have RC x y ready, then I can draw it. So I will ask G draw ellipse. PNS, and right now I'm not going to specify the color, so I use red and then IEC somehow there. Well, if something screw up, you just need to figure it out. I mean, to make a preliminary arrangement of this stuff. And I'm not going to cover everything. So connector, you need to draw it by yourself. So somehow at least we have this kind of drawings, neuron drawing ready there. All right, so we will go back. So our MLP is ready for drawing somehow. So let us go back to our form. So this time, since we learned everything, so right now I kind of dock back this speed container. So in our form, we will have an object, right? MLP, the neural network. initialize that equal. We do not provide any constructor. C# programming language will provide a default constructor for you. So right now we have MLB ready. So in case right now it's this guy, panel 1 need to, well, probably, suppose it's panel 1 need to draw this this neural network, right? So panel 1 is subscribe pen event here. Alright, so we need to using the guarding condition. If the net not equal none, right? Only when the neural network is ready, then we draw that. So the net draw NN, right? So you provide your graphics device to let this MLP draw its figure on your device. That's the whole idea. So E.graphics, E.quick rectangle. That's it. Alright, so let's see what will happen. Nothing. Interesting. Panel 1. Did I make it right? Spirit container 2. Panel 2. So let me see. Let me debug it. Alright, we actually here. So we entered. Came to this way. Bound. We do have bound. Alright, so probably something wrong is there. Largest one, so I get a largest one. That should be the 9, right? Alright, so how about the width setting? Width setting, whoa, it's wrong right here, see? 1000, okay, it's too large. Alright, I made a mistake right here. So what I'm going to do is bound height divided by largest one. Rectangle, we have bound. Well, it's interesting. Times 3, height times 3. What am I doing? Let's just try to determine the size. Nine, 10, height. 200, 400 divided by 3. Oh, okay, I made a mistake. Divided. Sorry about that. So make sure the width is okay. 16. Well, it's reasonable right now. Alright, everything has been drawn, but it's not right, because I might have offset. So we'll start. Why should have an offset anyway? So modify a little bit. Let me quickly modify a little bit. MLP draw it. So I have W. I have W right here, and then W, right? So probably not just +1. Plus 0.5. So INT everything, and then I might have INT X offset equal and that length -1 time W. Bounds width minus this guy times W divided by 2. Okay, so my rectangular x is here, x offset plus. Let me see, is it okay or not? So I don't need it to debug it again. So width should be 16 again too. All right, so it has been centered with respect to the rest of the chart. You see, once you have dynamic determine the width, once the screen is enlarged, you see your circle is also enlarged too. So that will make sure everything is working. Relatively, the size is okay for you. So you can draw this line. So what's left is that you just add the connector to each line, and then you can also place your weight, if you like, put your weight on the line there, and also you can feel a color. Feel a color for each neuron, or probably type of neuron value there. So just help your user, get an idea of the structure of your neural network using the graphics. So as you can see, we kind of carry out the object-oriented design, right? This is a multi-layer perceptron. It provides a draw function for the user interface to code it. That's the beauty of the object-oriented program, object-oriented techniques. So later on, if user like to print out, use a printer to print out the graphics, we can do that. So for example, right now, if I add a button, TSB print preview, and the face text, call it print preview. You had better use the computers and icon to let user know, well, this button is for print preview. So the display style, image and the text. Right. Once this button is clicked, we can preview the print content, and this one is for print. TSB print. Okay, so in order to perform printing, what kind of coding we should do? Well, you have already done that. Since your LP has a draw function ready, then we can ask the printer to print the graphics. So once you have everything drawn on the panel on the screen, then you can put these contents into a printer. So you can do that. So how can we do that? Well, once you click, as you can see, if you click a print, right? For example, you like to print something out? No, not here. Well, usually we have dialog came out, right? Yeah, it's the same. So take a look at the category of the dialog. Nothing. All right. So, but we have a category called print, right? Print right here. So we need to, at least you need to have a print document. So it's an object, print document. So drag a print document in. It's a print document. So we might rename it PNTDOC, print document. The content of this document will be sent to the printer and to print out there. So what kind of content you should specify within this document? We subscribe its event, print event. So once this document is about to print, then printer will go to my function, execute the drawing instruction there. So that is the whole idea. So print document, once you drag in, once you prepare a print document, then we should subscribe print page event. See, there's the print pages event. So subscribe it. So now we have a function ready for it. It's a little bit like the pen event. See, there's also print event. It's a little bit different. For the panel, it's called print event argument. But for the printer, it's print page event argument. But take a look at the E, the argument E, dot. You see, we also have the graphics there. How about quit rectangle? No, we do not have a quit rectangle. Instead, we have what? Page bound. We have page bound. So it's the same. I mean, so for printing, well, we just subscribe the print documents print event, the print event. So in this case, we simply copy this statement. If the n not equal, then the n draw line. But because our E does not have a quit rectangle, right? Instead, we just invoke its page bounds. That's it. So we have a print document ready for us to use it. Then we will subscribe, not subscribe, we will use a dialog, print dialog, print preview dialog, these two. So we have two kind of document can be invoked by the user interface. Drag in the print document, drag in another, not another, just the other print preview dialog. And then we have better change the name. This is called print preview document dialog, right? Yeah. DLG preview. And the other print, DLG print, DLG print. So the only setting is so simple. For this dialog, right? Dialog needed to have a print document associated with it. Then this print document command can be executed. So take a look at the property of this print dialog. You see there's a document there. It's very easy, just set the document into the print document. So when this dialog has been popped out, interact with the user and the user hit print command, then this print dialog will ask the print document get printed. So the idea is simple. How about print preview? Similarly, print preview is a dialog, right? So the print preview dialog also has a document property, can be specified by the user. And what we need to do is just specify that should be our print document. So everything has been bridged together, right? Has been set to link with each others. Then we can carry out a print command. Okay, so let us see what will happen. Right now, up to this point, so we add a print functionality here. We did not do anything yet, right? We did not subscribe the print the button yet, so nothing will be drawn. All right, so let us go back to these two buttons. So this is print preview, right? So we double click it, subscribe the quick event. In quick event is simple. We just DLG print preview, right? Show dialog. So every dialog object always has this function, show dialog. And I think that's it. We don't care about whether user cancel it or accept it. We simply just show dialog. That will be enough. Print preview. How about print? Print right here. So similarly, we subscribe the click event from this button, and then we just ask this dialog, print dialog, show up for the user to interact with it. Show dialog. That's it. All right. So we have our neural network drawn there, right? So we like to print preview. See what happened. You see, it uses up all the pages as the bound to draw your neural network there. Can I print? 我们这边可以列印吗 ？Okay. So let me try. 我已经送出去了，那 by default 可能没有设 printer, right? Can I need it? No, can I use? Okay, so for drawing, it's very simple. I mean, so once you prepare this drawing function, it can be printed to any device. Okay, for example, the screens or printers is very easy. It's not a big deal at all. So try to make your graphics display as complete as possible. 不一样嘛？对，刚启动而已嘛，对不对？它还在第二章还在送吗？有吗？哈，还在列印当中嘛，对不对？刚才我送了，应该如果说是有连接，应该会出来。Okay, so let us take a break. If you like to follow up, you can perform the similar operation. So let us take a break, and then we will be back for the rest of the topic that I'm going to show you. I might teach you how to use Excel to display your numeric data on Excel file. So later on, your research can perform another computation. For statistical evaluation or whatever. Anyway, all right. So let's take a break, and then we will back to continue with the next topic. This diagram shows the installation of your Visual Studio right now. So right now in my computer using C# programming language 2. Other application should be the machine learning, right? So you can include Python development environment. Also, I think should be R language, right here, Python R. So make sure you can, if you like, you can explore the programming functionalities of Visual Studio provided for AI, for Python, for R language, for F# language. You just click on it and then install it. You can use Visual Studio to write Python code to SSR language through the Visual Studio. So make sure, I think it's probably the problem came up from here. So later on, if you have time, you upgrade your installation anyway. Okay, so I think that should be your issue. Okay, so we add, right? So at least you can check what kind of class, what kind of interfaces has been specified within these references. So never mind, if you have time, you can check. Well, for example, we might have we need to access this one. I guess that should be application class. A lot of enumeration application. I do not have a filter. Okay, application class. Actually, we need to access through this interface application. And also, since Excel, the file itself is called a workbook, right? So we have a workbook interface ready. W. We have workbook class, workbook. And also we should have worksheet class. So these are the most important interfaces we are going to use. Anyway, later on I will show you how to do that. So after we include these references, then we can interact with Excel. So let me show you an example. For example, suppose right now I have a button. Try to write something. Okay, write something to Excel file. And save it, right? So the common way is that. So I try to subscribe it. So in order to interact with Excel, the first step is that you add these references. Actually, it's a DLL to your project, and then use namespace. Using Microsoft, right? Microsoft dot Office dot interrupt dot Excel. And this is the common way. You use this one, but for this length, it's quite lengthy, right? Because right now, in our window, we have application ready there. Application. Windows Phone we always has application there, but unfortunately in the Excel we have another class called application. So in order to not mingle with this application, we need to specify that. For example, right now, what happened? Drawing. What happened? Okay, the reason is because I added this user interface, so similar things happen, right? Let me comment it out to see. You see, once I added this reference, because in this namespace there has own this namespace has its own rectangle stuff there. So the class name is the same, but in different kind of namespaces, so it's kind of confusing. See, once you move your cursor to here, the image is showing that well cannot converge from rectangle to drawing rectangle. Why? The image does not seem right. But never mind, we kind of just pass using EX. Equal. EX is an alias. We specify anyway. No. Okay, we have EX. So right now it's not activated at all, right? If I move it down, image came out. Okay, so I kind of use this alias EX. So EX equivalent to this whole namespace space, right? So in our phone, we need to have an instance or Excel application. So we will EX dot application. It's interface, right? We just check that. So within these references, we have an interface called application there, and then we like to name it the Excel. And if you are familiar with Excel, once you open this Excel application, right? By default, you will new workbook. 活页簿哈. The formal name is workbook. And you can add a sheet, worksheet. So object-oriented wise, application is an object or application. A book, a file, right? A book is a file, is a workbook. Currently, is always has one sheet activate. So it's a worksheet. That is a document models or Excel file or Excel application. So similarly, we will have the Excel application ready first, and then we have ex.workbook, the book. We will need to have a worksheet, the sheet. So let us prepare a variable there first, and then in the properly in the appropriate time. For example, right now when button 2 is hit, we instantiate an instance or interface. So the Excel equal new application. Never mind, just let us see what happened, okay, step by step. So I kind of terminate the Excel application. And then I pop out the job management. So job management showed up currently, the application running currently, right? So you can, as you can see, currently we have opened this Visual Studio, Camtasia. Okay, we can close this guy. So if you terminate it, Adobe terminated, and check the rest of the thread, computer thread. See, there is no any Excel running, right? no any Excel application is running, right? All right, so let us execute up to this 9. So once I hit this button, came to this place, initially Excel is none, right? It's none. So once I run it, nothing came up, right? But because Excel has been activated, but in the background, not in the foreground. So take a look at this project management. You see, Excel is right there, Microsoft Excel. It has been open for your programming to interact with, but it is not open from the command, right? So nothing shown up in the Windows, but it exists there. So later on, you need to quick it, close it carefully and nicely, right? So once I finish it, you see, once I finish it, Excel will be gone automatically. But to make sure it is closed nicely, you should eventually ask the Excel quit, close it, and then release all the resources. If you want to release one application, it is not it's a native application. You need to ask a guy, process coordination guy called Marshall, M-A-R-S-H-A-L, Marshall, M-A-R-S-H-A-L, dot. That we just help you. Runtime, system.runtime interop service is a service provided by the platform, a .NET platform. Try to manage it. Marshall release COM object, the Excel. Okay, you need to execute this line. Then the background activated Excel can be released completely. Otherwise, you will end up there. Okay. All right. So once we have Excel, then we need to get the workbook. So the workbook came out from what? From the Excel. There is a collection called workbook. It's a collection. We need to add a new one. Add a new one. So it's optional. The argument is optional, so we don't have to provide anyone. So once this function is called, add will return will return a book, workbook back to me. So then I use the book. I think the variable name is the workbook, right? The book equal the workbook add. So once I have that workbook, naturally, by nature, I mean, let us this. Well, we cannot see anything anyway. All right, so the book is ready. Then we will get the book worksheet collection. It's a collection, so we can use indexer. The zeros. Unfortunately, since Excel is developed in C++ programming, so it's a native code, it's a native application. And the index is not started from 0. Remember that interrupt target is not C related programming language. It's the index is always start from 1. So we pick up the worksheet, the first worksheet, assign it to the sheet. And then the sheet is similar to this sheet. Okay, so Excel. So once you open an Excel file, right, you create a new workbook, right? There is a worksheet ready for you there. You can add another one, add another sheet, add another worksheet. It's okay. But right now we simply take the first worksheet as the target worksheet. We like to write something there. And for each cell, it's very simple. I mean, you can access that. So this is the sheet. The sheet cells use the indexing, okay, row index, column index. But as I mentioned before, it always starts from the 1, not from 0. So remember that. So I try to access these cells. And usually cells has a value specified. But right now we simply just directly assign a value there. So we try to put hello Excel. I mean, in this cell, right? So that's the whole idea we like to have. And once you write everything is ready, you can, what can you do? You need to see, we need to save, right? We need to save the book, save us to somewhere, right? This is the way we do it. So we are saving into an Excel or SS file, right? So that's the whole idea. So we like to save it. All right. So since we like to save it, so we actually use a special file name. So we dynamic pop out a save file dialog. DLG new, kind of new as save file dialog. And then specify its default DLG. Default extension shall be XLS XS. Fine. And then we will pop out the dialog DLG.show dialog. If the result user really want to save it, equal what? Dialog result dot OK. Right? So we get the file path from this dialog. So in that case, we will ask the book save or save as, not save as. See, we will supply the file name, and then I think the rest of parameters are optional, so we don't need to special each of them. Save as. Where is the file path? DLG.file name. So we save it. So once you save everything, the cell will be quit. The module will release object, and then remember before we release the COM object also, because the workbook also take up the resources. So module is a service classes release COM object. Because the book is still, the book is also a COM object, so we need to release the books first and then release the Excel application. Okay, those are the whole ideas we like to have. All right. So we write something to a book. So in this place, which line by line, you see, Excel is original none, right? So we create it. Takes a little bit of time, CPU time. Still running. Okay, so Excel is ready right there. So check it about the job manager. You can see Excel is right there. Excel is right there, right? And how about the book? How about the workbook? Workbook is a COM object anyway. So we execute it. So the book is ready. We have the book ready right now. And we pick up the first worksheet. How about the sheet? Okay, the sheet is ready there. How about Excel? No, nothing. Okay. So we have write hello Excel to this Excel file. So we pop out the dialog, default extension there. So let us save into the desktop. I will call it A. Save it. So the book saved. It's saved. Then take a look at this guy. Okay, they say quit. Release the book first. Release Excel. Let us proceed. Well, it's still there. Never mind. If I close application, disposal the resource. Okay, by that time the Excel has been closed correctly. So let's check the file aaa.xlss file, right? So take a look at this this place. Hello Excel has been printed there. So this is the way we write data to Excel or Excel file. Okay, so you use this one. But how can you read it? So this is the write to cell. If you want to pick up value from cell, the code is a little bit different. For example, we know it's a string, right? So we like to have string s equal what? We try to read back the content of the cell we have just put it there. So in that case, you need to do what? The sheet dot cells 1.1. You cannot simply do that. You cannot simply do that. So let us see what will happen. Take a little bit of time to create instance of Excel application. All right, so we write hello Excel to this cell, and then we try to get it back, put it into the string. Error came out, exception came out. Okay, see now we are cell itself is in the COM object, cannot convert it into your string. So the value is the content is actually stored within cell value, the property VALUE, the value. So you need, in order to write, it's okay, you directly write everything to this cell. But once you want to get a value, you need to use that value to get the value back. Okay, so that is the place you need to pay attention to. Okay, take a little bit of time. You see, as you can see, I terminated my execution, right? So the last Excel instance still exists there. It is not closed, not released properly. All right. So in that case, you need to pop out the management or the thread, and then clear the thread by yourself. So I get a value. Try to get a value. All right, it's okay. Right now, it's okay. SNet. Yeah, we get back the original string, hello string there. Okay. So this time specialize BBBB.x and continue with it. And then if I close it, see, there are two instances there. Once I close it, in this time, this guy has been properly released, so it's gone. But the previous one is still left there, so you need to go back here and kill it by yourself. Okay, so how about if we have something, for example, right now, if we have something here, for example, we have a label. LAB, probably root square R M, root square L. And we do have content. We do have content. I mean, once we train our neural network, we have shown up right here. So we can say root mean square L equal 0.0051555. Anyway, suppose right now, probably you might have a rich text file. Anyway, you will have some information stored within a label or within the rich text file. And you like to copy. We like to copy this content to what? To paste that into your Excel file. You need to record this stuff. So the easiest way is now you repeat this assignment one by one. You simply just copy the contents of this control and then pass into the Excel file. So how can you do that? All right. So right now we know we have what? We have a label. Root square text, right? So if we would like to print the contents into, we like to make a copy because probably this content is very big, very large, right? A bunch of information has been stored within this. Maybe I should use, excuse me, Maybe I should use rich text box to let you see, to let you appreciate what I'm going to teach you. Okay, so I have a rich text box. Rich text box. Suppose right now I have text, especially okay, chapter 1. Next line. And probably tab a key. No way. Okay, tab a key. C. Tab key. D. So probably you have a formatted text. Alright, this is just for example. So probably you have management a lot of information within the control. So this one is rich text box. RTB display. And you like to copy all this stuff and into your Excel file. So how can you do that? So I'll get the string first. RTB display text, right? So I got this guy. The first thing is that we try to copy everything to the clipboard, and then we pass back the content of clipboard back to the Excel. So that is the idea. So we're not going to directly display that on Excel at all. So we will ask this guy help us clipboard set data. That means you store the content of this object into a clipboard. Set data. Not just say that again. Should be set data object. Set data object. Set data object. So I kind of, in this way, you kind of copy the contents of rich text box into the clipboard. And then, if I want to pass it back, the sheet, copy. You see, copy the sheet to, oh no, not this one, clipboard, paste, not copy, paste. P-A-S-T, paste. You see, paste the contents of the clipboard onto the sheet. Destination, you need to special destination. Suppose the destination is the sheet, sales, second row, second column. I just specify this location, okay? That's it. The sheet passed. The sheet sale 2. So let us see what will happen. So this is the content I have, right? Click on this ball. Let it run through. So take a time to instantiation and application of Excel first. And then execute this line, execute this line, execute this line. So specify the file name, right? CCC is time CCC.excel. Alright, so that's it. So I close it, see? Close it. It's gone. And then check the CCC. Okay, so that is the beauty of cut and paste. What happened? See, I have tab specified. So once you get a tab, it will be arranged in a different kind of cell. So right now, the content has been well formatted, well organized in the grid. So that is the beauty. So I pass everything to this cell, right? But since we have a tab, we have next line, so every data instance has been placed in different kind of column, different kind of row. So that is the beauty of cut and paste. So this function I need to let you know. So once you have a well formatted content display on your user interface, you simply copy all the content to the clipboard and then pass it back to the cell. Excel can arrange this content in the grid, for you. So it will save you a lot of time. You don't need to reformat it You don't need to make a grid to collect all the elements one by one. Okay, that is the Excel function that I want to let you know. Is there any question about what we have talked, up to this point? Okay, if you don't have, I might show you another stuff. Let me just grab one of your work to see what happened. I think that should be the last 11, the TSP problem, right? So I check some other guy down. Okay, check out Chen's work. We have a problem is when we display the route, the TSP route in the panel, right? And during the solution evolution, the panel look like a freaking. And I will show you how to eliminate the freaking, the image freaking. When you draw something on a panel, if you bump this kind of information, you should use this technique to eliminate the freaking, the screen freaking. So we open the TSP. TSP, where is it? Okay, TSP bank right here, tab 150. So see, we have drawing right here appear there, right? So when we extension ACO reset everything round to end, as you can see, it keep freaking, right? Screen look, well, it's keep freaking. Right? Freaking happen because the CPU keep running, right? Keep do the calculation, but for the user UI display, the time is not enough, so the figure look like freaking, and we'd like to eliminate such kind of thing. The whole idea is that we need to specify, well, this panel, this page is different. The rendering, graphics rendering should be used in different way. So we need to say that. But unfortunately, for the page or the panel, it is not allowed to do that. So I will show you how to do that quickly. So if you like to eliminate this kind of freaking, so let us go back to the project. Pop out your form. So let me check which one, what is the target, city and route, right? So this is the guy we like to eliminate the freaking. That should be tab page 1, tab page 1. Okay, so go back to the constructor. This is the constructor. So usually, if you want to eliminate the flicking, you will set the property, graphics display property a little bit different. So if it is a phone, right? If it is phone is what? Phone is this. And you should invoke a function called set style. Set style. Set what kind of style? Set graphics display style anyway. So the flag is control style. It's a enumeration. So select it. All painting. WN paint. All painting in WN paint, which means that we will have a user supplied, drawing anyway. So this is an optional setting, so we kind of ought to get another option. Another option should be the optimize double buffer. So we ask phone itself use double buffer to display the graphics content. So in that case, if you draw anything, something, it will draw to memory first, draw to the memory. Once you complete the drawing command, then one time it blew out the content of that memory to the screen. So in that case, you will not see any flicking at all. So what we need to do is that specify, invoke this function, and then set this parameter, and then set it to true. So this function invocation takes 2 arguments. This is the first argument. This is the second argument. It's 2. But unfortunately, phone allow you to invoke this function directly, but not the page. We have a tab page 1, right? The target is tab pages 1. We like to invoke this set style, but there's no way because set style has been hid by the .NET framework. So the only way we can access this style function is in directory. So we cannot do it, right? So, but we know the target is tab page 1. So we leave this name right here. So we prepare a mesh info. It's a new class, and so we let the Visual Studio add a reference for us. It's on the reflection. So we use the reflection techniques to get the function somehow. So we call M. And we need to get the type. TA tab page 1 get type. We get the type of the tab page, and then we get method. We try to get a method. Anyway, indirectly get the method property and put it into an object or method info. And then later on we will invoke that function via this main, via this method info object. So we get method, the name, set style. We need to specify another property because it's not public function, so we need to specify binding attribute. It's instance label because this function is not class scope, it's instance scope. And also this function is non-public. It's non-public. So we try to get this function, set style function. This function is hide by Visual Studio, so we cannot directly access. But somehow through the reflection techniques, we can get this function and store the function information in the M. So right now we get an M. So once we get M, we can invoke it. So M invoke indirectly. And since the function is object scope, so we need to specify the object. What kind of object? Tab page 1. Tab page 1. This is the objects. And how about parameter? You see the parameter right there. We need to supply 2 parameters. If you want to invoke this set style, right now we indirectly invoke this function via this method info. So we need to supply this argument. So we simply prepare object array, obj array, PAIS parameters equal what? Equal these 2 guys. Directly copy from this line. These 2 should be supplied as the parameters for set style, right? So we kind of duplicate the 1, put in the parameters, and then we invoke this function indirectly, put parameters there. So what I have done here is that since I cannot use tab page 1 to access its style function, right? So indirectly I get the function indirectly and put in the function information, put in the method info there, and then invoke the function indirectly. Ask this guy invoke its own its set style function and use this parameter as the parameter passing. So in that way, that's it. So in order to eliminate freaking, you need to find the target. Currently, my target is page 1. If your target is a panel, you need to use that panel. The object name, put it here. Get the method first, then invoke it. So let us see whether the freaking is eliminated or not. So open again, Taiwan 15, yes. So create an HCO solver, reset, run to end. No, interesting. Huh? Is that right? Take page 1. What's wrong there? Let me check it. Don't need to use that. So I'm almost done. Okay, so, stop it. Serialize. Take page 1. Why I have 2 instances? How come? Yeah, okay. Tab page 1, right? Tab page 1. So it does not work. Why? Tab page 1, tab page 1, invoke. Well, obviously it's fail. Make a final check. Non-public instance. Invoke. Let me set it debug to see why it does not work. True. Method. Invoke will not return anything, right? Alright, I cannot figure out why it does not have a better result. Okay, never mind. You can try that. I mean, it's probably because drawing, right? Let me check this pen event. Yeah, it's so simple, right? So you draw everything. You draw this guy, panel equip, e-graphics, take page 1. Alright, it does not work. I mean, it surprised me. Anyway, if I have time, I will take a look at it. And you can try them if you like. I mean, especially when you do the multi-layer persuasion, since you might have a lot of graphics to draw. So in that case, I mean, in this case, you need to specify this panel. If the graph is showing up in this panel 1, so you make sure you indirectly invoke a panel 1 set style to see if the freaking is eliminated or not. I think the problem might come from the another thread. And the drawing function has been specified in another DLL file, so probably that does not work at all. Okay, I think that should be all for today. Even though I did not finish, probably I will use up next Monday. Next Monday, if we can finish the presentation in advance, I will show you how to write multi-threading application. Because sometimes when we hit, so for example, when our meta heuristic argument, we try to run to end, right? We click on this run to end, but we cannot terminate it. We need to let it go through all the iteration that has specified, right? But sometimes once we hit the run to end, we like to click it again and stop it. Once you want to do that, you cannot, I mean, accomplish this task at all, because we just have a main thread, one main thread to deal with the graphs display and also the computation. So in order to terminate it during the execution, you need to write your program in multi-threading mode. So In the next Monday, if we have time, I will show you how to write a multi-thread application in order to provide a termination capability for your meta-heuristic algorithm later on. Okay. All right, so that will be all for today. Is there any other question? All right. You're coding? Okay, fine. I will leave here. Okay, if you don't have any question, you can leave right now. All right.